Hello everybody, welcome back to the fifth video in our first unit on EDA. In the previous video we saw kind of a quick refresher on Boolean indexing, and in this video we're going to do a little bit more complex of an example. So to start out, I have NumPy imported as NP, and I have exactly the same code from last time that creates this 10 by 3 NumPy array of random integers between 0 inclusive and 5 exclusive. And the goal of this video is we want to get the subarray of ARR of all rows which have at least 2 2's. So for instance, this row here we would discard versus this last one we would keep because there's at least 2 2's. Very good. So let's start by making a 10 by 3 Boolean array indicating where ARR is equal to 2. And again, the way we can do this is say ARR, ask where is this equal to 2? And here we get 10 by 3 array where it's false everywhere that it's not equal to 2 and true everywhere where it is. So this is looking good so far. Now remember, what we want to do is count or kind of measure how many of the rows have at least 2 2's. So the way that we can do that is by using something called an access keyword argument. And that's exactly what we're going to do in this next part. So using the sum method with access equals 1, find how many 2's there are in each row. So the way this works is we can say ARR equal to 2. And now what we want to do is we want to say, let's take the sum, and notice we want to count in this direction, right? So if you're familiar with the access keyword argument from Math 9 or other classes or applications, then you'll know that access equals 1 means I can imagine collapsing in this horizontal direction, versus access equals 0 would mean collapsing in this vertical direction. So I'll link a video above in the cards explaining a little bit more about this access keyword argument. For now, if you'd like, all you have to kind of keep in mind is that access equals 1 will take the sum in this direction, access equals 0 will take the sum in this up and down vertical direction. So here, let's do access equals 1. And what's happening here is it's saying if we look at the first row, none of them are equal to 2. So let me kind of remind us what ARR looks like. So here's ARR. None of them are equal to 2 here. Exactly 1 is equal to 2 here. There's 2 in this row. And just skipping all the way to the end, we can see there's 3 at the end here. Quick reminder too, if you're coding along at home, remember we generated ARR using seeded random number, so you should get exactly the same values that I'm getting. So this is looking good so far. We've counted how many 2's there are in each row, and now what we want to do is just ask, well, how many of these rows have at least 2 2's? So that would be anything greater than 1, right? So this row and the last row here. So what I'm going to do is I'm going to call this counts, and I'll copy it and put it in a new cell just so that we can still look at it. So this is going to be counts. And now what we want to do is ask, well, where is counts strictly greater than 1? You could also do greater than or equal to 2. So it's saying here the 0, 1, index 2 row gives us one example, and the index 9 row as well. So again, hopefully familiar from a previous video. Now to get the subarray, all I need to do, and my keyboard shortcuts have decided not to work again, so let's add a code cell. So now all I have to do is say ARR and say take ARR where counts is greater than 1. This gives exactly the 2 rows that we saw before, so 2 0 2 and 2 2 2. So this is looking good so far. Here we used an intermediate variable, so we had counts. We could also do all of this in one line. It's just going to look a little bit more complicated. So what I mean by that is I could have instead done something like ARR. Counts, we said, was we're going to take ARR equal to 2, take the sum along axis equals 1, and now we want to ask where is this equal to 1. So notice we get exactly the same thing here. It's just this code maybe is a little bit more intuitive, easier to read. This one, if you were seeing it for the first time, it might take you some more time to pick it apart. So we've seen a number of examples now of using Boolean arrays to keep certain rows. We could also pass a list of indices telling us which rows to keep. So here's an example. I could do, well, let me remind you, what does ARR look like? So remember, there's 10 rows. This is the index 9 row. Remember, counting in Python starts at 0. If I did something like ARR, and then I passed a list of indices. So let's say I want to take the index 9 row. I could say 9, 9, 9. And what this is going to do is it's going to return index position 9 row 3 times. So here we get these 2, 2, 2s 3 times. So notice here I use these double square brackets. Kind of what was the point of that? Well, the outer square brackets tell me to do indexing, and the inner tell me the list of rows that I want to take. And here we're saying take index row 9 and repeat it 3 times. Instead, oops, and I moved it. So instead, what if I had tried something like ARR, and then what if I did 9, 1? So what this is going to do is it's going to say go to index 9 row, take index 1 element. So remember, and this is probably a bad example because all of these elements are the same. So let's try it with 8. So it's saying go to index 8 row, go to index 1 element. This is 0 element, this is 1 element. So drum roll, this should return 3. And it does, that's exactly what we want. So again, this is good practice too with remembering that counting in Python starts at 0. Another thing that we could do is, let me kind of do one more comparison. So we had here with the single brackets, let's do it again with the double just to kind of see the difference. So ARR, if I do now the list 8, 1, does anybody see what this is going to return? So again, this is going to give me index or row at index 8 and then row at index 1. So it should be 1, 3, 0 and then 2, 0, 1. So let's see. Yep, exactly. So 1, 3, 0 and then we have 2, 0, 1. Now, one question I'll pass to you. So think about how you would answer this, and if you get stuck, reach out for help. But how could you do this sort of indexing but with columns instead? So what if instead of repeating index 9 row 3 times, what if I wanted to repeat index 1 column a bunch of times? So think about how you could do it. One last example I want to do, it's a pretty straightforward example just because I'm going to give us a one-dimensional NumPy array now. So I could say b equals np.array. And I'm just going to create a sample array really quick. So let's do like 2, 1, 4, 3, 6, 7. And let's see, what was the shape of b? So kind of how long is it? So I could do b.shape. And it's saying it has length 6. So now what I can do is I can say b and pass now a bunch of conditions, right? True, false, true, false. So let's say I want to keep 2, 1, and 7 and get rid of everything else. Oops, and look, I split the comma again. Editing me here, there was a really subtle mistake that just happened. Did anybody catch it? Originally we had this 2, 1, 4, 3, 6, 7 NumPy array. And what happened is I had highlighted some text and the values got swapped. So that's kind of a text editing feature that kind of messed up our example. But then I didn't reevaluate the cell. So kind of the output was different than what you might have expected. So let's redo the example really quick. So here again, I have the NumPy array 2, 1, 4, 3, 6, 7. So we run it. I can see b.shape is length 6 NumPy array. And now I just wanted to show really quick how we could index using true and false directly. So let's say I wanted to keep 2 and 1 and also 7, but discard everything else. So like usual, I have the brackets for indexing, and now let's pass a list of true and false. So I'd have true, true, false, false. So 4, 3, 6 needs to go, and then we can keep 7. So we run this and we see we get 2, 1, 7. All right, I'm gonna pass it back to regular me. All right, I think this is a good place to end the video. In the next video, we'll talk a little bit more about that access keyword argument, see some more examples, and then in a video after that, we'll refresh on how to define functions in Python. Thanks for watching.